Good evening, everyone. Uh, Welcome to our webinar on remediation of learning gaps, looping back analysis to the classroom. Thank you so much for joining us and spending an hour of your Saturday with us. We really appreciate this, and we hope that you find value in our session and also find it engaging for you. Before I begin, let me introduce the facilitators for the session today, starting with myself. I am Sumita. I'm a subject expert in math in the EI CARES math team. I'm joined by my colleague Yuvraja, who's also a subject expert in math in the EI CARES team. So the session that we are going to take today, I think is at the heart of effective classroom teaching for us. What does it mean by what and how students are learning? So in our session today, the agenda includes looking at principles of good assessments. How do we move students from becoming well-trained to well-educated? And through the course of the session, you will see what we mean when we say this. In the same framework, we will look at how CARES, therefore, comes as a viable solution option, where it is not only serves as a very important tool for measuring student performance, but also an extremely powerful lever of remediation within the classroom. We end our session with a very interesting concept called the zone of optimal uh, learning and how CARES kinds of helps us to reach that zone of optimal learning. We will end the session with a dedicated Q&A session. We would request you to please write your questions in the Q&A box. Also, I would like to say that at the end of the session, there is a feedback form. We urge you to please fill the feedback form so that we can send you the certificates for attending the session. Okay, let me begin the session. So I begin with a very interesting and a true story. And I think it's a story that you all likely might find familiar. So this is a conversation between a parent and a child. The child comes to the parent saying that in her geography class, she has learned a very important fact. And the fact is that the distance between the equatorial and the polar circumference of the Earth is about 72 kilometers. The father was very excited. He said, well, good. But do you know what equatorial circumference means? The child nodded. She said, I'm not very sure. Okay. The father quizzed further. Do you know what polar circumference means? Maybe, maybe not, the child said. Okay, by this time, the father was kind of exasperated. He said, okay, do you know what circumference means? She said, no idea. But then she said something very profound. She said, I know that the answer to the above fact is 72 kilometers. And this is all they will ask in exam. So I think I'm exam ready and I will do well. Now, tell me that this is a response that we have not heard in our classrooms from our students. What did this story tell us? It said that the child is not that it didn't misunderstand the content, but the fact that she was not able to understand it completely. And this is what happens when the questions that we ask in classrooms, they assess memory, but not understanding. Here are some questions on the screen. I would like you all to have a look at these questions and tell me if there is something common that jumps out at you when you look at the questions that are here. Do you see any pattern and the kind of skill that these questions are testing? Would you be able, if you could just write it in the Q&A box, then we can check. Is there anything that jumps out at you when you look at how these questions are asked and what exactly are they testing in terms of student learning? I'll just take a pause here for a minute. Okay, so the point here being that these questions test more of how a student memorizes facts rather than the real understanding. For example, let us look at this question that tests for proof of rationality of the fact that root 3 is an irrational number. Sure, when you look at the question stem and you see a word like proof, you might think that it is asking for a higher skill. But actually, any student who has gone through the steps of proof that are given in the textbook can reproduce a very neat and clean answer to the above questions. Similarly, this question on electric bulb. If you look at it, it might look like the question is based on a real life context. It is testing something involving a lot of logical reasoning and skill. But again, a closer inspection at this question, and we can see that it's actually a very easy plug and play kind of a question. If the student knows the formula, then there are very clean values that can be put into the formula and the answer can be arrived. How about the last question that we see? Define atomic size, give its unit of measurement. These are questions that we see on and on at the end of the exercise of a chapter. Sure, these are important to know. I'm not saying we should not know, but a question like this, does it give you any idea of whether a student has actually understood the deeper concepts in the chapter? So what I'm trying to get at through these questions is that when we ask questions that reward students for how well they have learned facts or how well their memory is, we are not doing true service to the actual learning or understanding of a student. One second. Yes. So okay. So now let us look at this question that in contrast to the one that we just saw, let us look at this question. This is a question on which asks you to find how many light sources are there in the picture. And a student who would not have understood the deeper concept of how shadows are formed might actually count the number of light sources seen in the picture and would answer 2. And you will be surprised to know that almost 50% of the students that we tested in grade 7 and 8 have actually picked the number 2 as the answer. So this shows, therefore, that the student himself or herself, when this chapter was taught, has not fully understood the concept of how shadows are formed and therefore has picked a very uh, obvious answer in that sense. So this is what happens when we are testing questions that just test students on rote memorization of facts and not actually on whether they've understood the concepts that are being tested. Let us look at another question. So like I said, this is what our data said that 51% of the students have answered option 2. Let us look at another question on the right. This question asks you, what is the chemical formula of pure steam? You would by this time think that, well, it should be an easy question for grade 8 to answer. But look at what our data says. It says that almost 51% of students have said option D, which is that pure steam does not have a chemical formula. Now, why do you think this happens? This happens because when we teach concepts like these in the classroom, there is a separate chapter on chemical formula and there is a separate chapter on states of matter. And students have been trained to answer questions on these topics in a particular manner. So when we ask a question like this, and by the way, this question is from our care school, it kind of asks them to link both those concepts together and test the deeper understanding of and their reasoning power. And we see that more often than not, students falter at this stage. So it's very interesting, therefore, that when a majority of the questions that we ask from our students in the class are created like this, where they are clean, predictable, memory-based, questions students do not have a chance to develop deeper understanding. And also as educators, we do not get the correct insight on whether our students are learning or not. So what does a pattern like this do? A pattern like this in classroom sets a very cyclical and a vicious cycle of where teaching becomes superficial, where it is mainly focused on how to deliver content so that syllabus is completed on time. This leads to us framing poor questions, questions which can be answered easily if a student has spent time enough on understanding, on going through the facts in the chapter. It leads then reinforces superficial or surface learning in the student as well. Because like the story that we saw, where that child thought that just because she memorized that fact, she would score well in the exam, and she may well have, that she has understood the chapter very well. So surface learning in students then in turn promotes shallow thinking. And at this stage, I think it's very critical here that as an educator or a teacher in the classroom, we might feel that the child is not ready for deeper instruction. Now, that's not a very correct insight to get from the way we've asked our questions. So it might again lead us to not push the child to learn deeper or higher level concepts, but we may refine or restrict our teaching to basic concepts. So what I'm trying to get at is that when we assess students on their memory, we are shaping the way they learn, and the way they learn would not be very useful for them in real life or as they go higher on. It's a learning that will not stick with them. Okay, so then the question comes, so what are we really preparing our students for? Let us look at some questions. These are questions, they are real questions. These are questions that we found across boards, across subjects. And like I mentioned in the initial slide, does something jump out at you when you look at all the questions on these screen? Does a question like, who among the following was the first Director General of the Archaeological Survey of India? Does it do anything to tell you that the student has understood the relevance of this organization or what it is doing in the contemporary frame? No. It is testing a basic recall fact, which honestly, I do not think students need to know who is the first Director General of the ASI. Similarly, let's look at this question 11. This is a question on the tangent to a circle. It's a very straightforward fill in the blank kind of a question. If a student has read the chapter on tangent, has memorized this line from the textbook, he or she will be able to understand and fill the gap. But does that tell you that they've understood what actually a tangent is? Similar case with questions, let's say asking for chlorofluorocarbons, or questions like these which call for students to write direct definitions like what is consumer awareness, define the term market. All these are questions that are again based on cookie cutter mode. And this is what our assessments are actually testing students on. So then let us look at another question. This is a very interesting question. So the reason we picked this question was that if we look at the question stem, it uses the word analyze. And you might think, well, that's a higher order thinking question because analysis is an high order skill. But look at the rubric that the question expects a student to answer. It gives you 5 points. These points are copy pasted from the textbook. So while we are asking them a question, which is asking for some kind of analysis, what are the answers that we're expecting out of the students? It is again a copy paste answer type of a question, which the student, if he has mugged up or analyzed or learned all the topics in the chapter, he or she can easily reproduce an answer as pretty as this. But does that tell you that he has understood well? Or is that something that we want our assessments to train students on? That's a question that we will explore going forward. And so then what do? We move our students from well-trained to well-educated. And how do we do that? It starts by asking good questions. I would now ask Raja to take us to this section.
Thank you, Sumita. Good evening, everyone. I'll be taking you through a couple of sections. So my colleague Sumita has just laid out the problem that when assessments reward memorization over understanding, we create a cycle where students become well trained in giving expected answer, but not well educated in actual thinking. So how do we break this cycle? The solution starts with questions we ask. Good questions have the power to transform learning. They can distinguish between students who have simply memorized procedures and those who truly understand concepts. They can reveal misconceptions that need to be addressed. And importantly, they can actually encourage deeper learning and learning. Let's look at these two questions. The first question says, draw two trapeziums. We expect most students to be able to answer the first question correctly. However, second question tests for the real understanding of what trapezium looks like. This also stimulates students to think about whether shapes 1 and 4 are trapeziums, as they look different from the usual diagrams that students usually see in their textbooks. Let's look at how we can distinguish between mechanical learning and conceptual understanding. On the left, there is a question on finding the surface area of a cylinder with the given dimensions. This is a formula-based question where students apply a memorized formula, substitute the numbers, and calculate the answer. It's a procedural task, but it tells us nothing about whether students understand what surface area means. On the right, this question asks them to reason. The cylinder is cut into two halves, and one half of the cylinder is shifted down. The student must recognize that no material was added or removed. Therefore, the total surface area remains the same, excluding any internal surface area now exposed. So the correct answer is same as, but it's surprising how many students don't say that. This question tests their spatial reasoning and conceptual grasp of what surface area means, not just how to substitute numbers into a formula. Let's look at another example of how we can move from mechanical learning to real understanding. The traditional question simply asks students to explain photosynthesis and respiration. And what typically happens is students memorize definitions and just reproduce them without truly understanding the processes. But look at the alternative. This question asks which of the following schematics correctly represents the exchange of gases by a plant at different times. Students see 4 different diagrams showing gas exchange during day and night, with sun and moon symbols to indicate the timings. To answer this correctly, students need to understand that plants carry out photosynthesis during the day and respiration in both day and night. This visual representation requires students to think about the actual processes happening in the plants rather than just memorizing definitions. Let's talk about the difference between mechanical learning and real conceptual understanding. On the left, we see a perimeter question. It's a direct recall question. Just add up the sides and you're done. Many students will get it right. But what does it tell us about their understanding of what perimeter actually means? Now look at the right side. Which of these shapes has a perimeter? This seems simple, but only 39.8% got it right by selecting both shapes 1 and 2. About 34% chose only shape 1, likely because it's a regular polygon, it's familiar and easy to visualize. About 16% chose the shapes 1 and 3, probably because they associate perimeter only with shapes that have straight edges and defined measures. This is a classic case of procedural versus conceptual. Students can calculate a perimeter, but struggle to define what a perimeter is. So here is the takeaway. The first question tests calculation. The second reveals misconceptions. And that's where real learning happens. Let's look at another pair of questions that seem simple, but tell a lot about how students are reasoning. On the left side, we have the same perimeter question. Sorry.
You want to go back to this side?
This one, yeah.
Okay.
We have the same perimeter question. It doesn't reveal much about how they actually understand the concept of measurement. Now compare that to the question on the right. It asks how to calculate the area of rectangle. But notice most common answer students gave is 49 plus 37 plus 49 plus 37. That's the perimeter and not area. This tells us something powerful. Students are confusing area and perimeter, likely because they memorized formulas without developing a conceptual understanding of what these measures represent. This is not a calculation error, it's a thinking error, and that's what we want to detect through good questions. Here is another example of how good questions help trump misconceptions. Look at these questions about mass. The question on the left asks students to define mass, and 87% students correctly state that mass is the amount of matter in a substance. They have just memorized the definition perfectly. But now look at the question on the right. Anupam takes two identical papers, he crumples one and leaves the other one flat. When asked which one has more mass, only 27.8% correctly say that they have equal mass. And a shocking 44% believe that crumpled paper has more mass. And 9.5% think the flat paper has more mass. This reveals a critical disconnect. Students can recite the definition of mass, but they don't truly understand that crumpling doesn't change the amount of matter. They are likely confusing mass with density, volume, or even just the visual appearance. Now, this is an example of a question that develops higher order thinking skills. At a first glance, this might seem like just another volume calculation problem, but notice what's happening here. Students need to use information that when the flask is turned upside down, the water from the spherical part exactly fills the cylindrical portion. This gives them a crucial clue about the volume of the sphere. They need to reason spatially, understand the relation between the two parts of the flask, and then work backwards to find the total volume. This is not just about applying formula, it's about visual reasoning, logical deduction, and understanding the concept of volume in a practical context. These two questions perfectly illustrates what we mean when we say that assessment isn't just about math. It's about what kind of thinking the question activates. Look at the two fraction problems that appear to test the same mathematical operation, division of fractions. The question on the left asks, what is 25 1 by 2 divided by 1 by 2? This is a straightforward procedural question where students can apply the memorized rule that multiply by the reciprocal, that is, flip the second fraction and multiply. Now look at the question on the right. Which of the following figures describes the fraction of the shaded parts as 1 by 3 divided by 2? This requires visual reasoning, number sense, and a genuine understanding of what division of fractions actually means. Students need to think that if I have 1 by 4 and I divide it by 3, I'm asking how much is each part when 1 by 3, 1 by 3, 1 by 4 is split into 3 equal pieces. They need to look at the visual representations and understand the conceptual meaning behind division of fractions. Now let's look at the results. The procedural question on the left had 57.4% correct responses, while the visual reasoning question on the right had only 24.3% correct. This suggests that while many students can follow the procedural steps, far fewer truly understand what division of fraction mean conceptually. Okay, now that we have seen how the right types of questions can transform learning from mechanical memorization to genuine understanding, let's step back and look at the bigger picture. What makes an assessment truly effective? It's not enough to just ask better individual questions. We need to think systematically about how we design entire assessments. Over the next few slides, we are going to explore 6 key principles that should guide us when creating assessment, whether it's a classroom test or a unit test or a large-scale examination. Here is principle 1. Testing key concepts rather than peripheral facts. The traditional approach on the left asks for a textbook definition of a peninsula. Students can memorize this definition without truly understanding what makes peninsula unique. But the alternative question on the right requires students to analyze actual geographical features on a map and identify what they have in common. This tests their genuine understanding of peninsulas as land masses surrounded by water on 3 sides. Even if they can't recite the exact definition, they demonstrate real conceptual knowledge by recognizing the pattern across different peninsulas. This slide perfectly illustrates principle 2 using unfamiliar context to test understanding. Instead of asking students to simply state that friction generates heat, look at how this question presents the concept. On the left, we see thermal infrared images that show heat radiation. Students learn how thermal cameras can detect temperature differences, but the real test comes on the right with a pencil question. Students see an infrared image of a pencil where the writing tip shows a higher temperature than the rest of the pencil. The question asks why the tip is warmer. To answer correctly, there is option B, sharpened with a sharpener. Students need to understand that when you sharpen a pencil, the friction between the pencil and the sharpener blade generates heat, making the tip warmer than the rest of the pencil. This unfamiliar context, using thermal imaging to detect the heat from sharpening, ensures that students can't just rely on memorized responses about friction. Principle 3 emphasizes having questions across the difficulty range. Look at these 2 questions. Both test Pythagorean theorem, but at different levels. Question 1 is straightforward. Students are given a right triangle with 2 sides and need to find the length of the third side. This tests basic application, whereas question 2 is more challenging. Students need to recognize that the diagonal of a rectangle creates a right triangle, then apply the same theorem. Having both levels in an assessment ensures that we can accurately measure all students' abilities, from those just grasping the concept to those ready for more complex applications. Now, this brings us to principle 4, ensuring that difficult questions are based on good sources of difficulty. Good sources of difficulty include multi-step reasoning, unfamiliar contexts, or requiring students to synthesize multiple concepts. These encourage deeper learning. Bad sources of difficulty include tricky wording, obscure facts, or unnecessarily complex calculations that don't test understanding. When we use good sources of difficulty, even challenging questions become learning opportunities that motivate students rather than frustrates them. Principle 5 focuses on using authentic real-world data in our questions. When students work with actual data from their environment or current events, several things happen. First, the questions become more engaging because student can see the relevance. Second, they understand that their education has practical importance beyond the classroom. Third, these questions become teaching tools themselves. They are learning about the subject while also learning about the world around them. This approach encourages teachers to bring real-world connections into everyday instruction. Now, principle 6 is about continuous improvement through data. When question creators have access to how students performed on previous questions, they can create better assessments. This data tells us which questions were too easy or too hard, which ones discriminated well between different ability levels, and most importantly, what rank answers students commonly choose. Look at this example. We can see that 62% of the students believe plants only photosynthesis during the day and respire at night. This misconception data helps us create targeted questions and remedial strategies. All these principles work together toward one crucial outcome, that is, providing actionable insights to teachers. When assessments are well designed, they don't just give grades, they give teachers specific information about what their students understand, what they are struggling with, and what misconceptions they need to be addressed. This transforms assessment from a judgment tool into a learning tool that guides instruction and helps every student succeed. So we have explored how good questions and assessment principles can transform learning from mechanical memorization to genuine understanding. Now, I would like to hand it over to Sumita, who will show us how we can put these insights into practice with CARES and discuss remediation strategies. Sumita?
Yeah, thanks, Yuvraj. Okay, so what we saw right now is also the power of good questions, but also how, even with so much of reforms, our system or our assessment systems continue to reward students for memorization. So how do we fill this gap where we look at how students are actually really learning? And I think the CARES framework here can provide viable solutions for this, because the CARES ecosystem, with its huge data on student responses to questions, not only helps you give the right and the wrong answers, but, and most importantly, it highlights the common wrong answers, the misconception that majority of your students might have in your classroom. So, but how do we do that? And how is this data intertwined in the whole CARES framework? It comes through in the form of CARES reports. We have a few different kinds of reports. So in the next slide, I'm going to show you a sample student report. So if we look at the student report, it shows that the data is bucketed into three main categories. There is a data for overall score of a student. There is also data on how the student has performed on the basis of skill. So his performance on questions that test procedure or knowledge, and then on questions that test understanding and application. So this data here is telling us that while the student has performed very well on questions which are based on procedural understanding, his response on questions that test understanding and application is not that high. So what does that tell? That maybe this student is able to memorize facts and do steps, but maybe he is not able to apply those to contexts. So this is a very valuable insight that you get only when you have reports like this. It is an insight that as a teacher, it is very critical and powerful for you to know, because then it tells you the critical areas where you need to remediate learning gaps in your classroom. And in that sense, it also helps you in allocating time towards planning remediation activities in the classroom. So while this is a student report, CARES also provides a teacher report. Now, while the student report was at an individual level, the teacher report is a class-wise report. If you look at the pie here, this pie represents three broad categories of questions. Critical questions that we tag are questions that are very critical to understanding of core concepts in that chapter. And it is very important that those questions are revisited without delay, because then if these gaps are not addressed now, they might cause learning disability difficulties as the child progresses to higher grades. So in the report, we kind of tell you the questions that we have marked as critical. The second bucket is recommended. These are questions which are important to revisit, but they have a slightly lower priority than critical. And the third one is optional. These are questions where if as a teacher within the constraints of classroom teaching, if you have time, they're optional to revisit. So what does a report like this tell you? It tells you that how best to allocate your time in a way that it gives you maximum impact. What is the most common misconception the students in your classroom are carrying, and where should the limited time that as a teacher or as an educator we have in the classroom, how do we bucket that time so that the output that we get is the most efficient one? So this kind of a juxtaposition of student level insight along with teacher prioritization that comes on through reports like these that we get from CARES, they can help us give a very targeted roadmap for remediation and also fit within the constraints of classroom teaching or completing the syllabus on time. So I think that this is a data that is very, very important, and it gives you a very good insight as a teacher on how to plan remediation strategies in your classroom, given all the constraints that we may have. So what do we mean when I say common wrong answer? Let us look at this question. And this is a part of the report that we have. This is a very basic question asking for framing of a linear equation. The question reads, the sum of a number and thrice the number is 120. What is the number? Okay. Our data showed that when we asked this question to students in the test, almost 53%, and it was shocking for us to know that 53% of the students struggled to find the right answer. But what is more important is to know that these 53% of students picked option 3 as their correct answer. Now, why do you think they would have chosen option 3? I think if we look closely at the question, students who have chosen option 3, which is the most common wrong answer, have looked at the word thrice. They've probably understood what thrice means here. They may have formed the equation as 3x equals 120, solved and found x as 40. But what they have missed is that the question asks that it is the sum of a number. So if the only data that comes to you is that 35% have answered correctly, but 65% has answered incorrectly, what do you do with a broad pool of data like that? But when data comes to you segmented like this, where it tells you the particular misconceptions that students might have in solving the same question, it is a very, very viable and a powerful tool. So if you look at this question, it probably then tells you that there is a need to revisit how mathematical statements can be translated into simple equations before we actually move on to more complex framing of equations. So that's a very good insight to have. And the misconceptions that each of these distractors target are also very well thought of and not just random numbers that we put. Let us look at another example of common wrong answer. And this time I've chosen a question from science. The question says that Shikha, 12-year-old, loves to eat apple, and she decided to only eat apples for a month. Which of the following will happen as a result? What do you think the students would have answered here? So what we found was that, of course, we have kind of told our students from the beginning, like apples or fruits are healthy for you. So therefore, most of the students picked option 3, that apples are healthy food items, and therefore Shikha would remain healthy even if she only decides to eat apples for a whole month. But the correct answer is option 1, that since apples do not contain all nutrients, she may become unhealthy. Again, here, the fact that the segmented data tells you that option 3, which is more than half of your classroom, is not able to link the concept of a balanced diet to everyday nutrition is a very powerful insight that you are getting. It tells us that maybe there is a need for the class to revisit the concept of balanced diet, and also for students to read the questions more critically, look at the options with more reasoning and understanding rather than just picking uh, words that they think would be enough to answer a question like this. So this is also part of the CARES report. And again, like I mentioned in the previous slide, each of these options try to address one form of student misconception or the other. We look at one more common answer and how that is a very powerful tool, and that it comes from English. This is an English grammar question. It kind of tests the concept of tenses, but combines it with context-based clues. Here again, while the correct answer is option D, most of the students, and that is more than 60% of the classroom, which tells you it's a huge misconception, have chosen option 3. And if we analyze the question and look at as to why the student might have chosen option 3, I think the fact that they have seen the continuous tense used in the first line might have prompted them to choose option C. So this again tells you something, that while the student might have understood what tenses are, but the relationship between how tenses relate to changes in time across a given context, maybe that is the aspect that you need to revisit instead of the entire chapter on tenses. So again, this is a very, very powerful insight that you get from common wrong answers through CARES. We look at one final question, and I've taken this question from social science. It's a history question. And the question asks, why did people in India start to feel the need to form political associations in the late 19th century? Here again, the data was very stark and staggering. 65% of the students chose option C, option B, which is that they just looked at the word political association and thought that all political associations would have been formed for independence. So what does this tell us? That while students know the facts of political associations and independence, maybe where they lack is the historical sequencing of events. So then as a teacher, maybe there is a need to revisit how and where political associations, the genesis of them, how they started from their basic form to a more form of where they started asking for India's independence. So this historical sequencing of events, maybe that is one aspect in your classroom that you need to pick up for remediation instead of taking the entire chapter if there is a constraint of time. So this again is a very powerful data that comes only when you get data like this, which kind of address student misconceptions, and you have data points for each misconception. It is not a blanket data which says that 65% of the students in the class have not answered correctly. So therefore, it might tell us that maybe students have not read correctly or they have not prepared well. But here we are trying to address a more fundamental misconception. So this is the power of common wrong answer, and how a report that comes from a system like CARES can really be a great asset to you in the classroom in bridging the learning gaps in your students. So let us then, therefore, now look at how we understand learning gaps and remedial teaching. Uh, I will quickly recap the points that we've tried to raise by way of questions in the previous slide. So what are learning gaps? There are broadly three categories of learning gaps. Knowledge gaps. What do we mean by knowledge gaps? We mean gaps that come when students do not come equipped with the skills that they need for a particular grade level. What are skill gaps? Like we kind of showed in the DA report slide earlier, that sometimes students are more good at some skills and less good at the other skills. So while they may be very good in answering mechanical based questions, high order skills that involve analysis, evaluation, that there might be a gap in learning there. And finally, communication gap. So these are gaps that come from a student point of view. It would mean that a student is not able to express himself or herself in the class, and therefore there is a learning gap in what he picks up from the classroom teaching. How can learning gaps be created, therefore? Well, like we discussed, learning gaps get created when you have inadequate prior knowledge. What do we mean by that? So if a student is not equipped with the skills that he needs for a particular grade level and he moves to successive grade, he already comes with a learning gap from the previous grade. So his background knowledge itself is not fully adjusted for him to acquire new skills. So this becomes a major source of learning gaps being created in the classroom. Second is differences in learning styles and pace. I think that often a cookie cutter instruction style might not be suitable for all children. Therefore, should the learning style be customized to the learners in your classroom? That's a very valid point to ask, because if that is not the case, it might lead to learning gaps in the classroom. Instructional practices, what kind of instructional practices work with what kind of students? Should a project-based learning be more efficient? Should a visual-based learning, should a verbal-based learning be more conducive for your learners, is something that also might lead to learning gap if this mismatch is not addressed. And then there are other factors like language levels, absenteeism, which could often lead to learning gaps being created in the classroom. What is the impact of these unaddressed learning gaps? Well, it's very obvious. If students go from one grade to another grade without acquiring the skills, the concept knowledge that they require for that particular grade, of course, it will affect their academic success. It will reflect poorly in their grades. But I think a more fundamental impact of this is on student engagement. It is very important that students who come to classroom are not just passive learners, but they're actively engaged with the material being taught in the classroom. So if a student has a learning gap, I think that he or she is not able to connect with what is being taught in the classroom. There is dispersed learning levels there. And if a student is not able to connect with what is being taught in the classroom, what happens to his confidence level? It automatically goes down. And also his relationship with learning might not be very conducive for him to acquire new skills later on. So I think when there are learning gaps in the classroom, student engagement really suffers. And finally, as a result of poor academic performance and an uninterested student in the classroom, the overall holistic development of a student might also suffer. So it is very important that we address learning gaps and address them well in time. So before we close this session, we would like to introduce this very interesting concept of remediation loop that comes from Vygotsky's theory of social cultural development. And what this is essentially is that he says that students are not individual learners, but they are cultural learners, which means that every student, the culture in which he or she operates, has a great bearing on his cognitive development. So there are three zones that he suggests. The zone of can do alone is the zone of actual development. This is the zone where a student is very confident. He does not need any help and knows all the concepts. The outermost zone that we see, that is the cannot do zone. This is the zone of distal development. And here, what happens is that students in this zone are learning concepts that actually they are not ready to grasp yet. So it is definitely beyond their comprehension and cognition level. And the middle part, which is the sweet spot of learning, is the zone where a student is stretched, but just enough that with the help of a very knowledgeable guided instructor, they're able to acquire skills that are one step beyond his basic level of understanding. So this theory suggests, therefore, that it is in this level, that is the zone of proximal development, that if we target remediation, it is going to be most effective for students in their learning. And where does CARES come in? I think that CARES, with its structured feedback mechanism, targets students, that each and every student should come in this zone of proximal development. So what does a remediation loop then look like? Let's say we as students, as teachers, we form formative assessments for learning. Before we give formative assessments, we start with a predefined criteria for success. These should therefore hopefully should come from the kind of questions that we've shown you, where it is not just rote learning, but students are actually tested on how they've understood the concepts. Once the criteria of success is defined, once the assessment has been administered, that kind of assessment would give you data on how gaps are there in student learning. That feedback from identification of gaps then, as teachers or educators in the classroom, will guide us as to what kind of remediation strategies do we need to adopt. So like we said, if CARES comes in at this point in time, these remediation strategies would therefore be ideally should be directed at the zone of proximal development for a child where he is able to be stretched just enough that he acquires slightly higher level concepts. So it should not be at that stage where he knows everything that there is to know. So then if remediation is done at that stage, it leads to boredom because the child is already aware of everything that we are trying to teach him. It should not also be at the outermost zone that we said, where it becomes the concepts are so hard for him that it actually makes him disengaged and disinterested. So that sweet spot of where the child thinks that with a little help from a guided instructor, he can move to the next level would be very rewarding. And finally, once that remediation is done and we see results, the gap is closed of the learning level. How does this remediation loop then come in the context of EI cares? What does the EI cares ecosystem allow for this kind of remediation to take place? So on the EI cares portal, you make a lesson plan that you normally do. On the AI cares portal, you request for a test. You administer the test at a scheduled time that you have for your lesson plan based on your lesson plan. Once the test is administered, we give you the yearly reports, and we showed you a couple of reports earlier in the screen. You look at these reports, like we mentioned, would give you the CRO breakup, that is the critical, recommended, and optional questions breakup. They also come with questions that are defined as critical, and they tell you what kind of misconceptions these questions are addressing. So a misconception explanation also comes with it. And then finally, how you can remediate the learning gaps that come out through these reports. And to that extent, the reports come with certain strategies which can be picked up as ideas in your classroom to remediate the particular learning gap that has been come. So the loop kind of closes with this. Yeah. So before the last final point, before we close our session quickly, I'll share one example of how we are looking at misconception explanations and learning. How do we remediate learning gaps? So this is a question that has come from one of the reports, and it is a very simple question we gave to a grade 3 and grade 4 students, and we asked them to identify a triangle. Guess which shape they would have picked up. It's shape 3. And why do you think that is? Because this is the shape which is most similar to what they find in their textbooks, a typical equilateral triangle shape. So almost more than 60% of the students chose option 3. And only 9% of the students chose option 4. Why? Because it least looked like a triangle to them. So the misconception was captured through this question. We have an explanation as to how these misconceptions, that each option was targeting the misconception. But I want to show you a suggested remedial action that comes in the CARES report, one example of it. So the question that we just saw highlighted that students are basing their answer on the appearance of a shape. So we suggest a scaffolded remedial plan. Let us say the first level of remediation would be that we show students that a triangle is a closed figure which is made of 3 straight sides. Let them then give them a couple of examples of shapes and ask them only if the shape is closed and if it is made of 3 straight sides. Once students have been able to identify this very clearly, we move to the next level of remedial action, and that would be to expose students to different variations of the shape. So not just the kind that they see in their textbooks every day, but different kinds of triangles, thin triangles, fat triangles, long triangles, triangles which are tilted in different orientations, and see whether students here are able to reason that as long as the basic properties of a triangle is satisfied, are they able to identify a triangle? And the third and the final stage of remedial action could be we give them a classification exercise where we give them a number of examples, but we also give them a number of non-examples. And therefore, ask students to classify the shapes and justify why they have classified the shapes that they have. So yes, this is one example of a suggested remedial action that comes through the CARES reports. So let us just summarize the points that we have quickly tried to raise in this 1 hour with you. We stress that assessments must go beyond facts to test for deeper meaning. We also believe that when assessments are well designed, they will reveal misconceptions, and that is a very powerful strategy to guide remediation. Remediation is a loop. You start with diagnosing the problem, you then get to understand the problem, then we act on it, and that actionable data comes from a system like CARES, and then the process repeats if the remediation is not effective in solving for the student's learning gap. So then again, CARES then in that sense, it bridges this gap between the traditional assessments and what we are trying to achieve by way of students learning with real understanding, because it transforms the data that you get into insights and then finally insights into action. And finally, we talked about how the remediation loop can best be tackled if it is within the zone of the proximal development, that easy develop zone for children where if they are given an adequate guidance, they're able to master higher level concepts as well. With this, we close this presentation. I hope you found some value from what we've tried to share with you. If there are any questions, we will now have some time for Q&A. If you have any questions, please put them in the Q&A box and we will try to answer it. Yuvraj, do you see any questions that we can take up at this moment?
Yeah, there is a question on how is cash different from asset?
Could you take that up, Yuvraj? So,
Seven.
so I think that CARES is more based on how you can remediate classroom teaching. It is based on how students can improve their performance in the classroom, whereas ASSET is a benchmarking test which kind of measures students' performance across a national pool of students. So yes, CARES is more geared towards improving student learning in your day-to-day classroom teaching. Would you like to add anything, Yuvraj, to this point?
No.
Yeah, so I think that to that extent, I think if you're looking to get good scores in ASSET, I think it starts with CARES, if I can put it that way, that it helps build the overall skill development of your students. It also helps to answer different kinds of, like we've shown, questions that test you on different skills like analysis, evaluation, not just mechanical questions that you would get from the back of his exercise textbook answers. So yes, I think that CARES is the stepping stone to a good ASSET score. How can we practice questions like a sample? So I think the best way to practice for questions, while we do not give a sample paper, but I think that when you come into the CARES fold and you take CARES with us, the question students eventually develop, get trained, like I mentioned, they get trained to answer questions which extract a little bit more out of them than just a very basic understanding of concepts. So once a student is within the CARES fold, with each successive test that they take, I think they build this skill. That is what our aim is, to eventually build skills in students to reason to think critically, to answer questions that test a little more than just recall of basic facts. Before we actually wind up, I just want to quickly mention that please, before you leave us, please do fill the feedback form that is there. There is a QR code that will be shared with you at the end of the presentation. Please scan the QR code and fill the feedback form. It gives us good insights as well on how we have done and what would you like to hear from us in the coming webinars. Yeah, so this is the feedback link, the QR link that we're talking about. Pez, I think we can close today's webinar. We are past 6 p.m. Okay, so let's stay for a few minutes while the participants scan the form and fill their feedback. I think there is another question I think that we can answer here, and that is that I think that what I meant when I said that CARES kind of trains students to answer higher level questions that you might see in asset. I think the CARES is also a very good support for teachers. Like I showed in the previous slides, the data that comes from CARES reports, it kind of eases the teacher's burden to analyze where the misconceptions lie. It gives you a very ready reckoner of what needs to be remediated. So if you have limited time in the classroom, you need not spend your time in teaching an entire unit again, but it actually pinpoints the topics or subtopics where students in your class might struggle. And so to that extent, I think it is a very important tool for a teacher to manage his time, his or her time within the classroom, because I know we all feel constraint of finishing the syllabus on time and other instructional activities that we need to take up. So CARES definitely in that sense is a very big, I think it's a big help for students, for teachers in the classroom as well. So yes, it can definitely help teachers to train students to answer more conceptually rich questions and see how their students perform when questions like these come in their assessments. Yuvraj, will it be possible for you to share the QR code again? There is some, yeah, please.
Should I share the PPT?
Yes, please. The QRs so that they have time to scan it and fill the feedback form. I think there is another question, Yuvraj, on whether CARES can help them prepare for CBSE board examination. Would you like to take that up and how we prepare sample question papers for board
Yeah,
exams?
yeah, we do prepare. Uh, we do give papers based on
Yeah.
CBSE board. We prepare sample questions based on the latest uh,
Yes.
sample questions provided by the CBSE every year.
Yes. In the exact format that CBSE has, along with the different question types like assertion reasoning or case-based questions. So yes, we do create sample question papers for board preparations. Do we have anything else on the chat? We have a few minutes. So Yuvraj, I think there is one question where somebody is asking what happens when remediation fails. What would you suggest? So I
Again,
think, yeah.
then we can try on some other
Yeah, for
method.
being a loop, I think there is a case in point to try other targeted remediation.
Yeah.
It's definitely a loop there. Okay, we have someone.